Very good afternoon. My name is Priyanka, and I am an assistant executive engineer production, posted in Institute of Oil and Gas Production Technology, ONGC Mumbai. I want to brief myself. So BTech, I have done BTech in chemical engineering from NIT Hamirpur in 2017, and then MTech in chemical engineering from IIT Roorkee. I have a 3 years of professional experience in upstream oil and gas industry, which includes crude oil and natural gas processing, scale and corrosion, and production monitoring and optimization. So I am also specialized in high-C simulation for process design, performance modeling, and optimization. So my presentation outline will be I have done for this. What about the paper background, the basis of study, scheme conceptualization, simulation studies, and then summary. First, I will be covering background. So in one of our onshore assets in northeast, there are 7 gas gathering stations, from where around 2.65 MMSCMD of gas is being transferred through our owned pipelines to one of the power plant. So the gas which being supplied contains heavier hydrocarbons, which on removal on condensate through hydro dew pointing provides the opportunity for generating VAP products, value added products. So this study is basically carried out to conceptualize the scheme which will facilitate the minimum condensate formation in the transportation pipeline, and generate the value added products, and will also meet the gas specification that for the sale to power plant. So for the basis of study, the study is based on the various inputs. So first is 2.6 MMSCMD of gas, which on dew pointing. Dew pointing means cooling it up to 0 or minus 5 degrees Celsius. So here the 2.6 MMSCMD of gas is being bring to minus 5 degrees Celsius at 14 kg per centimeter square pressure, where the produced condensate will be 64 meter cube per day. So the feed for this VAP production will be around 64 meter cube per day of DPD condensate. DPD condensate is mainly NGLs, natural gas liquids, heavier hydrocarbons which are being present in natural gas. So this is the basic input data, which I have done this study in Aspen HYSYS. So the input data which is being required is flow rate of the gas, and also the composition which is around the methane, ethane, and all the gas components which are present. And after the simulation, after the dew pointing, this is the DPD condensate simulated values that. Methane is around 14.82%, ethane is around 2.07%, propane is around 2.15%. So mainly propane, butane, and heavier components are for the LPG and naphtha products. So for the scheme conceptualization, so the gas which is received in the gas metric station, so where the dew pointing has been done, and after that the DPD condensate is first fed to the stripping column, where the off gases, mainly methane and ethane, are separated out from the this column is also called LEF column, and from the bottom of this this column, the bottom is fed to the LPG column, where the LPG and naphtha will be recovered. So the basically the scheme for DPD condensate feed are, so the DPD condensate at around 64 meter cube per day from hydrocarbon dew pointing of around 2.6 MMSCMD of gas at around minus 5 degrees Celsius at 14 kg per centimeter square is considered as a feed stream, and this condensate is then fed to the LEF column to remove the light components, and the bottom product is from the stripper column is fed to the LPG column. From the LPG column, LPG is being extracted as a top product, and naphtha is extracted as the bottom product, which are considered as the sellable products. So simulation model is being developed in Aspen HYSYS software based on the above process description. So simulation study, this is the model which I have been modeled in Aspen HYSYS. So first the feed is fed to the separator where the off gases are separated, and then to the stripper column where the results are around 64 meter cube per day of condensate, around 1.6 meter cube per day of LPG, and 59.2 meter cube per day of naphtha will be produced. And for this, around these these are the products, but we have to match them with the IS specification. These are the products which have the density. This is the IS specification. So parameters are for vapor pressure for LPG, it will be 520 minimum and 1050 maximum. So my product, the product which is being simulated in the Aspen HYSYS, the vapor pressure will be 714, which is in the range. So this is specified as the LPG product. And for the naphtha, the major specification will be 70, that is read vapor pressure at the 37.8 degrees Celsius kPa max. So the simulated product will be 25.66. So this will be considered as a naphtha. So after this, the revenue which will be generated from these products, which are the LPG is around 189 crores for the annual revenue, and for naphtha it is around 8 crores. So total revenue will be 197 crores for this. Actually this is only a conceptualized scheme, so it will be not implemented yet. So this is just a conceptualized scheme. So coming to the summary, so the supplied gas from the onshore asset of ONGC, which contain the heavier hydrocarbons, have a potential to generate VAP products when gas undergoes through the hydrocarbon dew pointing process. So the gas is chilled to around -5 degrees Celsius, and then the model is prepared in Aspen HYSYS software for generation of value added products as per IS specifications. So after simulation, it has been indicated that around 1.65 meter cube of LPG has been produced, and naphtha is 59.18 meter cube will be produced. So this will be it from my side. Thank you.